Okay, good afternoon, ladies and gentlemen. It's afternoon here, and today we're going to talk about Lewis dot structures. And this is what we're going to be doing this week, is doing all these different types of Lewis dot structures. And first, what we have is, let's talk about a little bit of vocabulary. We learned about this last semester, or last month, valence electrons. Basically, the electrons in the highest S&P orbitals, highest energy level, I should say. So, let me get my pen going. So when we talk about this as the highest energy level, and we're talking about here with sulfur is the electrons in the 3s and 3p. Don't worry about the d yet. We're not talking about the d, it's just the s and p only. And so this is what I mean by valence electrons. And Lewis, over 100 years ago, came out with a theory about bonding. He was mostly right, but he said there's an octet rule. And he knows how all things were coming together. He said each atom would like to have 8 electrons in the highest S&P orbital levels. So they want to have 8. They either lose or gain electrons to achieve this. And so we look at sodium, 1s2, 2s2, 2p6, 3s1. This 3s will rather go away. So we end up having a 2s2, 2p6, which is 8 electrons in this shell, and is happy. It wants it to be there. This is like an extra electron. It can get rid of that easily. And chlorine, it's 3s2, 3p5. We add an electron to make it 3p6, and it's what we call stable. It will not react any further. And same thing with sodium. It's down to this. It will not react any further. It doesn't want any extra electrons, and it won't give up any more. For chlorine, you can't take away any electrons with this. It's hard to do, and it doesn't want to add any more. So we call this, the octet rule is 8 electrons in the highest S&P orbital level, so valence shell. And we want to have 8 in there. Now there are some exceptions to the rule. We've got hydrogen and helium. The maximum number is 2. And the reason why is because hydrogen and helium only has the 1s. And the maximum is in 2. So they can't have any more than 2. So for this, for Lewis dot structures, hydrogen and helium are 2. And this makes hydrogen easier because it only binds to one thing. Now, first 18 elements. This works for plus elements in columns 1, 2, 17, and 18. Other elements can follow this rule, and sometimes, and it depends on the situation, but sometimes it doesn't, especially with transition metals and heavier elements near the bottom of the periodic table. It happens. So we're just giving you the rules right now, how to work with the rules, and we're going to show about exceptions later. So when we talk about the Lewis dot structures, we're going to just talk about neutral atoms at this point. And we're going to, when we start off drawing these structures, we're going to use the chemical symbol for the element. So here we have one element, and we have this, we have 2 hydrogens. So we're getting used to figuring out how to write these things. And each side, and we're going to assume this in a square. So we've got carbon, and we've got this square, and each side contains 2 electrons. And we draw the electrons, and we want to put them along the line. So we have an extra one, we put them like this. And we start at the top and moving around. First, Hund's rule, empty orbitals first, and then after we put 4 in, we pair them up. So for example, we have carbon has 4 valence electrons. And so we got carbon 1, 2, 3, 4, and now and this is the Lewis dot structure for carbon, just by itself. And let's talk about nitrogen. It has 5 valence electrons. And so we draw N and assume we have a box on here. 1, 2, 3, 4, 5. These two dots are called a lone pair. So these are paired up, unreactive. If you have paired electrons, they're not going to form a bond. They won't come apart. But these three are available to accept or donate. So we got nitrogen have 3 bonds. So single electrons on the side. And so when we talk about single electrons, this is where we figure out how many bonds an atom can have. And it's usually true. There are some exceptions. We're going to say it's true for this class. Now, I'm going to give you the procedure on how to do a Lewis dot structure. We'll look at water. And this is how I want you to do it and how you want to solve. There are a couple ways to do it, but this one gives you the right answer 99% of the time, with the exception of some weird ones. And there's some other techniques we need to work with. But for the most part, we're going to look at this. So we're going to obtain the chemical formula for we're going to use water, H2O. Count the number of valence electrons in the molecule. So hydrogen always has 1 valence electron, and there's 2 of them. Here's the 2. So 2 times 1 is 2. So hydrogen brings in 2 valence electrons. Change that. So oxygen has 6. We have 1 of them, so there's 6 valence electrons for the sum of 8 total. So this is fun. We're looking at total valence electrons. And so what we're going to do is place the most electropositive in the center, but not hydrogen, because hydrogen only can form 1 bond to it. It can't be in the center where it can have more than 1 bond. So I'm going to put oxygen in the middle. Usually this is one of the exceptions. Okay, and we're going to take this and I'm going to bring this over to the next slide and bring this over to the next slide. So we have 8 electrons, 8 total valence electrons. And so we've got oxygen. And then we're going to place the hydrogen on either side of the center atom, and we're going to draw a line. So here are the 2 hydrogens, and we'll draw a line in between it. Each line is a covalent bond. And it has 2 electrons. Now, covalent bond is when atoms, 2 atoms, share 2 electrons. So this is important. So when we talk about these bonds between 2 atoms, this is indicating that these 2 electrons are shared between the hydrogen and oxygen. And now we used up 4. So 8, so we have 8 total. We used up 4. Subtract them, we've got 4 left. And we're going to place them around the most electronegative element first. So hydrogen is full with 2. It can't have any more. And you notice I'm using X instead of dots. You can use either one. And now I have 1, 2, 3, 4. 4 left. And then this should be my Lewis dot structure. So let's check your work. Here's my water molecule again. Each atom should have 8 around it, either shared or owned. So 1, 2, 3, 4, 5, 6, 7, 8. Oxygen has 8. Hydrogen has 2 on each side, so it's stable. So this is the actual Lewis dot structure of water. Now I want to point out is that sometimes you may see hydrogen water look like this. This is fine as well. It doesn't matter how we draw it, as long as you have two sets of unpaired electrons and 2 bonds connected to hydrogens, and you're fine. Notice that hydrogen does not have another bond to it at either one of these. It only can form 1 bond. Now with the exceptions, hydrogen must have 2, which we already talked about. boron and aluminum are stable with 6, and this is one of the things you need to we need to point out, because you're going to see either boron or aluminum in some of the example problems, and they can have 6 around it and no more. There is some different chemistry going on, and you'll learn that when you go to a higher level. But at this point, just stay with 6, and that's it. Ladies and gentlemen, have a good day. This is the lectures on Lewis dot structures, and we got 3 more coming on how to do the assignments. Thank you, and have a nice day.